Hello, I'm going to go over question number 5. I know from my previous class, students need some help with it, so I'll see if I can go through it and maybe it'll help you. So it's a question about someone pushing a lawnmower and looking at the forces and friction and things, and it deals with a 30-degree angle below the horizontal, so it deals with vectors. To start with, we need to have a good force diagram of this. So I'm going to draw a force diagram of the lawnmower. So we know there's a normal force, ground, lawnmower. There is I'm going to draw it a little bit bigger. FG, earth, on lawnmower. There, let's suppose it's being pushed this way. That's the velocity it's being pushed. That's the direction of the velocity. So that means friction is always opposing velocity, so friction is going to be in this direction. That's also ground on lawnmower. And finally there's the force, the pushing, and it says it's making a 30-degree angle and it's below the horizontal. So if this was the lawnmower, and here's the person, they're pushing down on the lawnmower in that direction. So we draw all our arrows on force diagrams pointing away. So that's the force push from a hand. And that's 30 degrees. So that's the starting force diagram. I'm going to redraw it. I'm going to, instead of using this vector for force, I'm going to replace it with FPY and FPX. So I'm going to use the components of that vector. So let's redo this diagram. FG, FF. I don't know why I do that so big. It should be the other way around. And there'll be FPX and FPY. So there's the force diagram. It has all the forces acting on it, and I think we're told that it's constant velocity. So all the verticals have to be balanced and all the horizontals have to be balanced. If we look at the horizontal first, it's the easiest place to start at. We have FPX, FF, and they're balanced because we know it's going constant velocity. So if we know FPX, it means we can also figure out the force of friction. And we can find out FPX by going FPX is 30 degrees. Oops, not there. 90 newtons times cos 30. So 77.94. And FPY is 90. Did I do something? Oh, darn it. FPY 90. Yeah, that's fine. Okay, so that's the vector of those, or the components of that vector. So now we know that force of friction is equal to essentially 78 newtons, because it's the same as the FPX. So that question A is done. And then we want to know the normal reaction force on the mower from the ground. Okay, so that's vertical. So for question B, we're looking at the vertical. So I'll just redraw the vertical. Fn. And then there's two forces pushing down on this. There's FPY and FG. And we can write, we can sum up the forces, write our F net equation. So F net is equal to 0, because it's not, this thing's definitely not accelerating upwards or downwards, and that's equal to Fn minus Fpy minus Fg. Or the other way you can think about it is just all the up has to equal all the down. And we can solve this right away, I think, because we know the mass of the lawnmower is 15 kilograms. So Fn is equal to, we've already figured this out, that's 45 newtons, plus Fg is equal to mg. So this is 15 times 9.8. And I get Fn equals to 15.8. 192 newtons. There's the first two questions. And if we want to do the bonus ones, yeah, I mean, we should do the bonus ones. They're actually not that hard. Calculate coefficient of friction between the mower and the wheels and the ground. So force of friction is equal to mu Fn. So mu is Ff over Fn. That was 78 divided by 192. .41. And B, calculate how hard the boy would have to push something to give the mower an acceleration of 0.8 meters per second squared. So in that case, if we go back to our horizontal, this is 90 newtons. Force of friction. That doesn't change. The force, well, maybe it does. Maybe it is a little bit harder. I'll just do it this way. This 90 newtons is the force of friction. Yeah, that doesn't. It'll change a little bit actually. Anyways, we'll just go with this. Fpx. So Fnet is equal to Fpx minus Ff, and that's equal to ma. So Fpx equals um, 15 kilograms times 0.8 plus the friction, which was 78. So I got a bit of rounding here. Back to 90. Okay, that's 90 newtons. And redraw a little triangle here. There's 30 degrees. This is 90. That's this. Fp is equal to 90 divided by cos 30. And I get 104 newtons. So there you go, there's the question number 5.